Hello, and welcome to Backer Breaks It Down. In this episode, we are going to be classifying triangles. Now, you may have classified triangles in grade school as equilateral, isosceles, scalene, acute, right, obtuse, and equiangular. Okay, and that's what we're going to do today. But can you tell whether it's acute, right, or obtuse if I just tell you the lengths of the sides? Well, you can use a Pythagorean inequality to do that. So a triangle has three sides, right? A, B, and C. So let's say that C is the length of the longest side. So if C squared is less than A squared plus B squared, the triangle is acute. If C squared equals A squared plus B squared, the triangle is a right triangle. And if C squared is greater than A squared plus B squared, then it's an obtuse triangle. Now, there is a way that you can determine what angle would be the smallest or what side would be the longest simply by knowing the measures of the angles and or the sides. The positions of the longest and shortest sides of a triangle are related to the positions of the largest and smallest angles. That being opposite the largest angle is your longest side, opposite the smallest angle is the shortest side. So let's take a look at some examples. Number 1 says to list the sides of triangle DEF in order from shortest to longest. Now, I realize that we're just given the angle measures, and we're not even given all three angle measures. We don't know the measure of angle F, and I feel that we should know the measure of angle F. So let's do some subtracting from 180. If I subtract 51 and 47 from 180, I get 82 degrees. So what would be the shortest side? The shortest side is opposite the smallest angle. So opposite our 47-degree angle, we have side DF. So what would come next? Well, our next angle would be 51 degrees, and opposite the 51-degree angle, side EF. So that side comes next. And that leaves us with one side, the longest side, and it just so happens to be opposite the largest angle. That's what makes it the longest side. So the longest side is side DE. So let's say we have a triangle with side lengths 5.3, 6.7, and 7.8. Is the triangle acute, right, or obtuse? Well, in order to determine this, we have to find C squared. Now, C is the longest side. So that would be the 7.8 squared, okay? So I'm just going to write this down. So I'm going to compare the longest side, which is 7.8. I'm going to square it. And I'm going to compare that to the other two sides squared and added together. So now we have to do some calculating. Now 7.8 squared is 60.84. 5.3 squared plus 6.7 squared is 72.98. So I think we all agree that 72 is bigger than 60. So we're saying that C squared is less than A squared plus B squared. So that means our triangle is acute. How are any two sides of a triangle related to the third side? Well, if I have three segments, those three segments may not make a triangle, okay? So if you look at these three diagrams here, three attempts at making a triangle, only one of them worked. We only got a triangle with the sides of 2, 4, and 5. I couldn't make a triangle with the 2, 2, 5, and I couldn't make a triangle with the 2, 3, 5. So what is the relationship? Well, we use our Triangle Inequality Theorem to determine whether three sides are going to make a triangle. And the rule says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so I have to do three tests to determine, is it going to be a triangle? And all three of these have to be satisfied. Okay, this is the Triangle Inequality Theorem. So let's take a look at some examples. Can a triangle have sides with a given length? Explain your reasoning. So remember, the sum of any two sides has to be greater than the third side. So with triangle A, if I add 5 plus 10, this must be greater than the third side, which is 15. And it's not, right? Like, this is not true. So this is not a triangle. Now 4b looks a little intimidating, but it's really not. So you have three sides, n plus 6, n squared minus 1, and 3n. But they also tell us that n is 4. So our three sides are 10 and 15 and 12. So let's do our three tests. Remember, the sum of any two sides must be greater than the third side. So if I add 10 and 15, is this greater than 12? Yeah, 25 is totally greater than 12. So that test has passed. So let's do the next test. So let's add 15 plus 12. This has to be greater than 10. Is it? Well, 15 plus 12 is 27. 27 is greater than 10. So it passes that test. So we just have one more test, okay? So let's do that test. So we haven't yet added 10 and 12, had we? So 10 plus 12 has to be greater than 15. 10 plus 12 is 22. 22 is greater than 15, so it passes. So this one is a triangle. Because the sum of any two sides must be greater than the third side. So a triangle has one side of length 14 and another side of length 9. Find the range of the possible lengths of the third side. So we've got a 14, a 9, and an x. So just remember, the sum of any two sides must be greater than the third side. So if I go 14 plus 9, this has to be greater than x. So 23 has to be greater than x. So let me do my second test. If I go 14 plus x, this has to be greater than 9. That means x has to be greater than negative 5, which kind of makes sense because like it has to be greater than a negative number. You can't have a side that's like a negative number. That doesn't make any sense. All right, third test. 9 plus x has to be greater than 14. So that means x has to be greater than 5. So if we were to put all of these together, we would get a compound inequality, right? And let's face it, it has to be greater than 5 and greater than negative 5. So x has to be greater than 5, and it has to be basically less than 23. So when it comes to the range is 5 is less than x is less than 23. And so that was the Triangle Inequality Theorem. Basically says the sum of any two sides must be greater than the third side. And that's how you can determine whether three segments will make a triangle. And that's how Bakker breaks it down.